Hello, today we are making our packet number 7 video. It is due next week, Tuesday, February 11th. First thing, make sure your name is on the top. Put your finger on your name. Make sure you've got your name on there. On this first page, it says you throw 3 darts at the board shown below. If each dart hits the board, how many different possible point totals can you score? So, oops. We are going to pretend we throw that dart. Let's say our first throw hits inside that bullseye all 3 times. So we have 10 plus 10 plus 10. That point total is 30. So now I'm going to say, oh, I'm not always so lucky. This time I'm going to throw my darts and I'm going to throw and I'm going to hit 2 10s and a 4. 10 plus 10 plus 4. That gives me a point total of 24. Sorry about that, not 14. Gives me 10 plus 10 plus 4 is 24. So now I'm going to throw my 3 darts again. This time I say, oh, I hit 1 10, I hit 1 4, and I hit 1 1. So 10 plus 4 plus 1 equals 15. I'm going to go through all the different combinations that I can make throwing those darts. So like the next time, maybe I throw and I hit, do I have any hitting the 10s left to do? I've got 10, 10, 10, 10, 10, 4, 10, 4, 1. I do. What if I hit into the 10 and then I hit 2 1s? 10 plus 1 plus 1 gives me a point total of 12. Now you might be thinking, well, what if I hit the 1 and then the 10 and then the 1 and I hit 1 plus 10 plus 1? That gives me that same point total of 12. And it is asking for different possible point totals. So if I get the same point total, I'm going to cross off because I can only count that 12 one time. So there will be different combinations you can come up with that might give you the same point total. You can only count a point total once. But you're going to come up with a list of how many different combinations you can get to different point totals. Count them up, and that is going to be your answer over here. So I gave you a few. You've got to find all of the rest and figure out how many there will be. Okay, our next page your neighbor Henry is cleaning up his yard for the season and has already collected 7 bags. So he's already collected 7 bags. He's got 7 bags sitting over to the side. You notice that his trees have not yet lost all of their leaves, and when you ask him about it, he says he expects that as they fall, he will be able to collect another bag of leaves every 3 days. How many total bags of leaves will Henry have collected after 57 days? So if we're skip counting by 3s, and we get a total of 57 days, we're going to figure out how many days he actually collected the leaves into a bag. We need to divide it down. So that 57 divided by those 3 every 3 days. So we would have those 57 days divided down by 3 because he only bags them every 3 days. So you're going to find how many bags he's going to collect in those 57 days. And then don't forget, he already has 7 bags sitting over to the side. He's already collected 7. So you need to figure out what that total is. How many bags he's collecting in the 57 days, along with those 7 bags that he had already collected. You're going to do the math on that and put your answer on the line, showing your work. That is why your answer makes sense. Our next page is our 5-card challenge. We know we need to get 12 points. We need to have our answer be 5. So you have these 5 numbers. You do have a 5 to work with. You cannot say 5 equals 5. That is not an equation. An equation needs to have a math operation happening in it. So you can't say 5 equals 5 because there is no equation there. So you need to do an equation like 9 minus 4 equals 5. Okay, you could use the 5 in your equation to equal 5 because we have a 5 up here and then it can equal 5. But you cannot just say 5 equals 5 because that is not an equation. Our next page is our pattern page. So let's look at this. So on your page, it is black and white, but I labeled it. Yellow is the light square, red is the dark square. We need to count and complete for the total blocks in each figure. So it really doesn't matter if it's yellow or if it's red, because we're just doing the total blocks. So if we look at figure 1, there is 1 block. Figure 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Figure 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And if we count this next one, oh goodness, that is a whole lot to count. So if I have counted it all up, I will see there's a total of 49 squares. So now I'm going to look at that and say, what kind of pattern am I seeing with 1, 9, 25, and 49? And I'm going to tell you right now, remember what my favorite kind of number is, those perfect squares. Love me some perfect squares. We will see them in our patterns all the time. And if I look at this, 1 is 1 squared, 9 is 3 squared, 3 times 3 is 9. 25 is 5 squared, 5 times 5 is 25. 49 is 7 squared, 7 times 7 is 49. I am going to follow that pattern to complete my column of total blocks. 1 squared, 3 squared, 5 squared, 7 squared. Think about what's going to come next. What number will you square? 1, 3, 5, 7. What comes next in my pattern? So you're going to finish that pattern off for the total blocks. Our next page is our area page. Whew, I have to erase some more of my dots here. So this one's a little bit different than what we've been doing. It's not perimeter and area. Now we're working with a big figure, the full figure, and then we have a small figure inside of it. All work must be shown that we're doing. So first thing I need to do is find the area of the full figure. Remember that the area is length times width. So length times my width, so 12 times 10, put your answer here for that full figure. Now in order to find the area of the shaded region, I need to find the area of the white. Oh, how I found it, I put it up above, you could put it down here. 12 times 10. All right, so I need to find the area of my white rectangle. Again, it's length times width, so 7 times 2. And now I'm going to put that answer right here. Now I need to find the area of the shaded region. So everything outside of that white rectangle. How do I find out that? I need to take away the white rectangle from that full big area figure, the full big figure rectangle. So how am I going to find it? I am going to take my figure area and I'm going to subtract out the white area. And my answer is going to be that shaded area. And I'm going to put that answer right here. So I take my full area, I subtract out the white area, and I'm left with my shaded area. So that is how we do the math for this page. Our next page is our volume page. So for the volume page, we need to know how to find the volume of a sphere. So the formula for the volume of the sphere is 4/3 times pi times r cubed. Remember, r goes from the middle of the circle to the outside, and that is a 9. So my calculation is going to be 4/3 times pi times 9 cubed. 9 cubed is 9 times 9 times 9. You can put it into your calculator using that little caret key. Remember to do our exponent. 9 to the 3rd power times pi times 4. And then that fraction bar says we're going to divide it by the 3. And we're going to put that answer right here. Then for math 6, it says we have a sphere that has 1,200 milliliters that fills up 25% of the sphere. How much water is needed to fill the sphere 3/4 full? So if it's 3/4, I'm going to look at my sphere and say, well, that is 4 parts that I'm breaking my sphere into, and I want to fill it up 3 of those parts. So I need to look back and say, well, 25%, goodness, what fraction is that? So I need to figure out what fraction it is to be able to compare it to that 3/4. So 25 over 100, I can simplify that down by dividing out 25. 25 divided by 25 is 1. 100 divided by 25 is 4. Oh, 4 to 4, I have the same denominator, same 4 sections. So I know one section is 1,200 milliliters. I need to go up to 3 sections. So I take my one section and I multiply it by the 3 sections, or I could add all 3 sections together. Either add all 3 sections together or multiply by 3, and we're going to find out how much 3/4 would be needed to fill 3/4 of our sphere. All right, our next page, we have is a mean, median, and mode page. So we need to remember what mean, median, and mode means. Remember, the mean is that average. We add them all up and then divide by how many numbers we have. Median is the middle number, and mode is the number that we see the most of. Now, with some people who have already been working on this page, the mistake that they're making is they see, okay, 3 oranges for $1.20, and then 2 bananas for 99 cents, and then 4 tomatoes for 75 cents, and 3 loaves of bread for $2.50. The problem is we need to write, if it's 3 oranges for $1.20 each, that's the key word, each. So we need to see that 120 3 times. There are 2 bananas for 99 cents, so I need to see 99 cents 2 times. And so on. So figure out how many of each of that produce there are, write that amount each time. So if the tomatoes are 75 cents and there are 4 of them, I should see 75 cents 4 times. So you should have a total of 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 3 is 12. So there are 12 pieces of produce, 12 prices that you need to add up, so you can divide it by that 12 to find the mean. Then to find the median, you need to put them in order from least to greatest. So you can see what number is in the middle. Remember, if there are two numbers in the middle, you have to add them together and divide by 2. Then to find the most, see which number you wrote the most times. There is not a question being asked for us, so we do not need to put an answer in there. Just find the mean, the median, and the mode of all 12 numbers. If you still have questions with this, please make sure you come and ask me. Have a wonderful day.